Up next, we have Dean Tribble, the co-founder of Agoric. He's joining us for a keynote. He's going to be walking us through what the Agoric project is and how it functions and what their future holds. So I'll let you get to it.
Great. All right. Okay. So for people who may not know me or Agoric, I wanted to show my early version of a Chainlink t-shirt. Agoric was founded in 2018, and we've known the Chainlink folk for a long time. And we were founded by innovators, early pioneers in this space. So Mark Miller, our chief scientist, wrote the Agoric Open Systems papers, which are part of most anyone's canon for blockchain and online smart contracts. It was really the first articulation of autonomous agents creating and participating in markets. I worked on the first production smart contract back in 1989, which, carried the one. That was a really long time ago. And in particular, you'll note that that was a long time ago before actual blockchains were available. 5 years, I think Vitalik was 5 at the time. And so, but we found an immediate sort of camaraderie and spirit with Chainlink because we're so focused on very similar kinds of mission. So what's that mission, right? It is really to move all the ways that people cooperate, the diverse, vibrant world mainstream economy onto a decentralized web in a decentralized fashion by using smart contracts, but more importantly, by enabling the world's programmers to use smart contracts, right? I am not enough of a programmer. My company, Agoric, is not enough of a programmer. Us with all of you out there, we're still not enough programmers to be able to do all the economy online. And that's where we want to get to. That's where we need to get to. That's where we have a shared long-term vision and alignment to be able to bring the world in that direction. And so it was always awesome to talk to Sergey and the rest of the Chainlink team. So thank you very much for having me here. And I look forward to describing what we're doing and then what are we planning to do in collaboration with Chainlink. So first, it's been 30 years. What do we mean by smart contract, right? And sorry for the bright screen, but it is an enlightening idea, right? And a lot of people out there have a very vague, fuzzy notion of autonomous program or something like that. It is a contract-like arrangement between multiple parties expressed in software, expressed in code, where the behavior of that program enforces the terms of the contract. Now, this existed before blockchain. And so, if people are thinking about that, I've been in a smart contract, PayPal, Venmo, automated rental agencies, Airbnb, much of Amazon, all of those are upwards of $1 trillion in market cap from before there was blockchain. And if you add in high frequency trading systems, then it's way more than that. So what does blockchain bring to the party? Well, what is a blockchain? Our gold standard is multiple independent computers in different administration zones and different jurisdictions. So there's no single point of, shall we say, failure, that agree on data. They agree on choices, the order of events. Did I pay Alice or did I pay Bob? And they agree on the results of computation. That's the smart contract piece where they agree on the results of the computation.
But hey, Dean, really quick, sorry to interrupt you. I don't think you shared your screen.
So glad you came back. I'm going to do a quick flash through here.
Yep, that'd be great. Now we can see it.
Okay, good. You heard me here?
Yes.
You heard me here, right? Okay. Thank you for interrupting, and hopefully everything made sense so far. So multiple independent computers with no single point of failure, agreeing, whether with a vote or some other secure mechanism, on the data, the choices, and the results of computation. And what that brings us is computing with high integrity. And what that means is all those things that were trillions of dollars of smart contracts that predate blockchain, they all relied on trusted shared parties, right? Whether it was eBay or PayPal or Airbnb or Amazon or whoever it was a trusted third party that was going to run the software that enforced the agreement by people outside, right? That enforced the agreement between the buyers and the sellers. And that's hugely valuable, hugely leveraged. But what blockchain means is we can get rid of that trusted third party and instead make software components and software systems and applications to make all of that work together. Okay, So where's all that happening? Obviously, DeFi. And, in some sense, the mantra around DeFi, the way to think about it, is right now it is very exciting, but frankly, very dangerous. And we can talk a lot about what those elements are, and it's got strong limitations, right? We've got volatility is really killing several different potential use cases and costing a lot of our ability to grow. Slow finality is a challenge for lots of use cases. I mean, several talks in this conference have focused in on particular elements about the performance and the scaling limitations for real mainstream use cases. Similarly, it's also poorly structured for growth. Now, proof of work, I'm not even going to talk about it because that contributes to this terribly slow finality. But proof of stake systems also have economic problems where there's a pressure towards centralization because they're just early proof of stake systems and they haven't been in a position to be able to extend and iterate that so that they can do staking derivatives, so they can do other economics so that validators by themselves can leverage the assets under management, the assets that they are staking, and instead you've got pressure towards exchange staking and these other things simply because they're substantially more viable. So for proof of stake to be able to solve some of our scaling problems and to be able to solve some of our gas price problems, you've got to have more economics around that. And then finally, there is a poor developer experience. And I love the Justin's presentation just before that because he took you through a lot of pieces of what experts deep in the space struggled to be able to actually produce valuable things and maintain them over time. But it's more important than that. In Ethereum, in other systems, the architecture of them are such that they are simply fraught with security hazards, right? Whether you're talking about the hundreds of millions of dollars locked up from the reentrancy bug in 2018 for parity, or just recently, Open had a put that had a problem that they had to revoke, or yesterday, Dan Robinson and Georgios, whose name I will refuse to mangle, from Paradigm, analyzed a case where someone accidentally locked up 12,000 bucks worth of ETH. Those are all problems that it's not that you should be able to manage them. It's the infrastructure should have been such that you could not possibly have had those problems at all. Right? You should be able to write smart contracts that don't cause those risks for their customers. And it's not that it moved it around. It's not that you managed it. It's not that you insured it. It's that you never had to have it, right? Just like in a memory safe language, it's what we call a safety property. Just like in a memory safe language, where you just don't have a dangling pointer into memory that has arbitrary private data in it because you simply cannot express it. And it's not that solves all problems, but it takes 80% of them off the table. And so what that means is, a good 80% of the security breaches where people lost significant issue, and we can do that. We can achieve that with a next generation system. And then finally, back to the entire subject of the talk, DeFi needs composition, right? And composition is notable now because it's so rare in current systems, because it's so hard. And we'll talk some about what that should be like in a moment. But our goal, well, actually, I'll take a quick aside because of Justin's presentation, where he talked about they took an existing piece of code from the Ethereum thing and they edited it, and that was their contract. And that's hugely valuable to get that level of reuse. But what you'd like to do instead is take some chunk of code and not change it and be able to rely on its security properties that people have already validated and add something of your own in order to build something more. And so we'll talk a little bit about that. So what are we building? How are we solving this? Agoric is building a public chain and a smart contract platform, a sovereign chain. Initially, we start with fast finality from Tendermint. Now, we're not locked into Tendermint. We're agnostic about that. A lot of what it takes to make a real chain in the future of DeFi is the stack you build above it. But all of our economic architecture is integrated into what Tendermint and Cosmos SDK can do. And so we're starting there. Our testnets crossed 1 million blocks from there, and we'll be launching from there. And then we'll grow out from there to be able to leverage all of the advances in consensus like Avalanche that was discussed earlier, which has some really nice properties. And it provides, similarly, again, part of our architecture provides much more predictable gas economics, much more predictable means more business applications can allocate gas and predict what will happen in their business so they can be successful. You can get more composition, more opportunities, and more profits out of all of these businesses if they can operate in an environment where something that cost 50 cents yesterday doesn't cost $50 tomorrow. For us, our goal is getting millions of programmers to be able to do this stuff. And as I said before, with the existing security models, it's just never going to happen. It just can't happen. It's just too hard, where experts can't get it right. And all of the people that have had bugs or most of the people that have had bugs, there may be some recent potato-like things that may or may not be in this category, but most of them are real experts. They, really deeply worked on this stuff. They really, they did security reviews, they did analysis, and yet they still got bitten by some hazard in the system. And so that's not successful. And what we want is millions of programmers to be able to do that. One ingredient of that is it's got to be in a language that millions of programmers already know. And we have worked for nigh on 14 years now, integrating into JavaScript security provisions so that you can make a secure version of JavaScript. And so that's what we've built. It's being incorporated into products like MetaMask, into Node.js, which has crossed 1 billion downloads, and other systems, where it enables you to run JavaScript safely without it being able to escape and steal your secrets and all that kind of thing. And we use that as part of the core of our system. And then in that, build up an object-based set of APIs, just like if any of you have done React programming or Angular or used other interesting Stripe for payments, being able to have an object-oriented API is something that millions of programmers are familiar with. And it turns out in DeFi, it's crucial because it gives us tools to do very successful risk partitioning, which is one of the big values for getting defense in depth and securing and improving the economic safety of our systems. And then finally, it's built for DeFi from the ground up. We learned a lot from the work that many smart people have done before us, and we're leveraging it. So, in our system, there is a native stablecoin. We love everyone else. We want to bring them all over with interop, and we've worked deeply for interchain and interop starting from IBC. But there's an integral one that's part of the normal execution and function of the system to simplify and reduce the overall volatility that smart contracts are normally interoperating with. It has integrated simple AMM as part of that, but we enable permissionless addition of other contracts that are perfectly in a position to compete with this on the same system. And we enable taking the components that we build, whether it's for voting and governance or AMM as part of our underlying market, to be able to pick those up and not just take them as open source and adapt them, but just use them directly and plug them together with things. So in short, our platform, our target, our chain is programmability for DeFi, and programmability for millions of developers in the future for DeFi. And of course, other things, but frankly, DeFi is where everything's got to start. Okay, so you saw a lot of GitHub things. I'm going to do something different here. Back to that. What's the programmability thing? Can you all see the underlying Visual Studio? Someone asked me, 6 months ago, what are you going to do about a development environment? And the answer is, well, Microsoft has spent millions of dollars for us, so why don't I use that, right? So this is just VS Code unmodified, where the thing about being a familiar language is I get real command completion and normal IntelliSense and static analysis tools, and over here I've got standard testing tools with where I don't have to do anything special to get all of the DeFi work, all of the CI systems working and stuff like that. Oh, I made everything run slow so my video would go out well. So I will run this once here, but we'll let that run. And that's that's a set of standard tools. And what I'm looking at here is a reusable component. So here, this ran, by the way, this is Aave, which is a standard JavaScript system out there. And this component here, let's say I wanted to get rid of this, I can save that, and of course, it'll automatically rerun the test here. So what you're looking at over here is a covered call. Now, I show this because a week or so ago, there was a problem with a put option where Ethereum Solidity got another one, right? But here, what's going on is I've got this entire file is an entire smart contract, and it will start up. and if I collapse this, right, it will create an invitation for someone to make a covered call. And what they have to do in order to make that covered call is they have to provide the underlying asset and the strike price for that covered call. Now, an important thing about this, and this goes to that composition thing, is if you wanted to make a covered call of some underlying stock or of concert tickets or of an NFT, do you copy this code and modify it? And the answer is, in our system, you don't have to. Obviously, you can, but this underlying asset is any asset in our API, right? So any asset using what's called the electronic rights transfer protocol, which makes it very easy in the language to trivially create a new asset. And indeed, this is creating a new asset. The results of any contract is another thing that can be traded inside of markets, you know, put up for auction, sent to a person in their wallet, etc. And so what this gives me is I make a covered call. I could now take that covered call, sell it to you for 5 peg dollars, local stablecoin dollars. You get it, and what you get is a covered call with a strike price for an underlying asset that is, let's say, a concert ticket, or let's say it's a bunch of Apple stock. Same contract, same system, could be pegged ETH, it could be Ethereum, or it could be Bitcoin brought to Ethereum, brought using Althea over to Cosmos, transferred to our system with IBC. All of that is just asynchrony that's all, you know, that's all handled underneath the covers. This contract would be able to take that asset, give you a covered call that not only do you get it, but you get it only if the system verifies that it's an unexercised covered call for the actual asset you wanted, you know, that expires in a time frame you wanted. And that code is entirely right here. And when you want to go do an exercise, what it's going to do is it's going to take the assets you provided in your argument to the exercise and swap it for the stuff that the seller provided. And that's it. That's what the covered call is I can buy this thing that lets me do that swap in the future. And that's the entirety of it. And it's general across all asset types. So I wanted to show this because, you know, again, it's one of those things where seeing in this case really is believing, where it's standard JavaScript with kind of normal, normal JavaScript kinds of things. You know, I can, you know, move around with the standard navigation and all those kinds of stuff and run, you know, standard normal test suites and so forth. So that was something that sadly is completely different. But if we're going to go to millions of developers, we need to be able to reach the kind of developer experience that they expect. And so our standard is not, you know, a web-based thing that I can paste some code in and get stuff out. Our standard is what large organizations and small organizations and entrepreneurs in all sorts of different countries and millions of programmers around the world do on an ongoing basis. Okay, so what's missing? I said that we want to do, oops, I need to go to the right window. I said that what's missing is the real world, right? We've got an amazing system for composing, adding new asset types, bringing them together, doing DeFi, selling things on multiple markets, and automating that. Where, you know, for example, I mentioned our stablecoin. Our stablecoin can easily turn around and not just post something for auction when a vault needs liquidation. It can turn around and automatically sell it on a local automated market maker. And would that be better than an auction? Is it good that, you know, does it do rate limiting there? Can we compose various variations on that and evolve it over time? In our environment, we can, right? But the real world is missing. And that's what the partnership with Chainlink is all about, right? You know, in 2018 or even before then, you know, when I was describing oracles to people, I talk about it as the seers of reality. Obviously, this community knows that it's bigger than that. It's also being able to go back out to reality and tell it. But this really connected with a lot of people, for example, in the freight industry or in other enterprises, where it's just a system that connects the outside world to, you know, in this case, our blockchain, but in general, other blockchains. And it can report prices. It can transfer custody of packages by doing, you know, scanning. It monitor temperatures for insurance vehicles. And we heard lots of crucial examples here. And lots of people have thought about it, but none so deeply as Chainlink here. So why are we excited about Chainlink? I mean, you know, I've had people on the technical side, not in my company, but elsewhere go, yeah, you know, oracles are easy. Lots of people can do oracles. Is it difficult? Is it hard? Well, there are two kinds of hard, and there were talks earlier that focus on ways in which just doing an Oracle is hard the same way BFT is hard. Looks easy kind of on the surface, and man, you dig down and it's just fractal. It just kind of keeps going. The challenges of when people are misbehaving, or the challenges of making sure it settles in a reasonable time frame, and you have incentives to settle in a reasonable time frame, and all that is a deep problem that is hard the way consensus is hard, or hard the way that the implementation of a chain is hard. But there's a different kind of hard that I talk about. So, so most technologies focus on deep problems, where it's a challenge to implement things, and you're limited by the complexity and how small our poor brains made of meat are, right? But the other kind of hard is what I call broad problems, right? Payroll. Payroll is easy in some sense. I take your salary, I divide it by 52, that's how much I'm gonna pay you, and there's a couple of numbers, I do the multiply, and I'm done, and that's how much I'm gonna issue you. Oh, except that it's different depending on the day of the week. It's different depending on the month. It's different depending on the zip code in which you're receiving payments. It's different based on the tax, blah, 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 right? And what happens is it's hard because of the details. It's hard because I can do payroll today, but next month it changed because some municipality made a vote, right? And so it's hard in a different way than a deep system that requires a discipline, and it requires a focus, and it requires a bunch of these things, right? And that breadth means that even if I could implement an Oracle today, the same way that I could implement a covered call today, I shouldn't. I should pick up the existing component that already solves it better than I might, and I should use that because it'll do a better job. And that's the simple hard part. That's the simple deep part of it. But the broad part of it is even harder, right? The Sergey earlier talked about crossing the chasm. And one of the elements of crossing the chasm is you've got technology on one side where people just want a solution. But on the other side, where people just want the thing that does a piece of the job, right? The Oracle implementation. But on the crossing the chasm side, on the other side of that chasm, people need a solution. So it's not that I need payroll today. I need payroll that's going to work every pay period for the next 10 years. And I need a partner that knows how to do that, right? So I need people that are focused on the problem. I need people that have incentives for a long-term solution to be able to support this over time as the world changes out from under them, as I find things that I need to do. And I need that all to be in a community, because this thing is just bigger than one group can do, one company can do, one smart person can do, or one team of that. It requires not just me, not just Chainlink, but that larger community out there of all the people that I hopefully am talking to here. Because we need, all of the information you bring to bear, all of the assurance you can bring to bear on that information, all of the ability to adapt to its changes. And then we also need you to be able to be excited about what you can do with that to come into our system and build smart contracts that leverage that information to do awesome new things. And so from our perspective, there's the technology side where we've got aligned vision, and we've got a system that lets us get a price for our stuff, and that's really good, and that's really important, and that's crucial. But more than that, it's a thing that lets us provide a price, or provide prices, or a mechanic to get new prices that people need for permissionless people that I've never met and will never know, building things that I never would have thought of, in a future that I have yet to dream of. And that's the thing that's really exciting. And so, our goal, we talked about DeFi is exciting but dangerous. Work together, with our platform, with a data-rich environment that Chainlink can bring to our system. We can make DeFi a whole lot more exciting and a whole lot less dangerous, and that's our goal here. So, thank you very much. I will be doing a question and answer session afterwards, separate from this.
Yep, absolutely. So everybody, we set up by popular demand. The chat was absolutely loving it. Dean, loved the energy. Dean, thank you so much. It was a pleasure.
Thank you all.
Looking forward to the next one, that's for sure. And cool stuff with Agoric.
Watch
so thank you very much.
for what we're actually, all the details of what we're actually going to do and what we're doing with Chainlink. It's very exciting.
Awesome. Looking forward to it. Thank you, Dean.
Thanks, Dean.
Hello, Dean.
Hello, Abby.
Thank you so much for that keynote. I know we all needed your just infectious energy at this time of the day. So I'm excited that you're sticking around a little longer. I saw a ton of questions in the chat there. So it's like everyone's moving their way over here. There's already some people in the chat there. So I'll let you take it over from here and just chat it up.
Okay. And should I invite people onto the stage here, or just talk in chat?
Just kind of reading the questions out of the chat,
Great.
and you just answer them however you'd like.
Excellent. Well, Tom poked it to join on networking. So Tom Greco, if you're there, let me know your questions. I'm glad you guys enjoyed it. All right, folks, enjoyed it. There will be an Agoric token. There is no information about that yet. But yes, it'll be a layer 1 chain with its own sovereign chain with its own token and so forth. So there are two ways we will leverage Chainlink oracles. One is for data that we need. We plan to use Chainlink oracles for economic elements of our economy, right? So there will be an intrinsic stablecoin, for example, that as you can imagine has pricing oracles behind the scenes. We know where they're getting that. Staking will start probably this year, but we'll announce a lot more about when staking and when chain availability in the next month or so. But the other way that we will leverage Chainlink oracles is, here's the real plan, right? I showed you some JavaScript components. I want a JavaScript component, which is the price source, right? It's, we've got the easy ability to say, give me a notifier that changes when, my contract says the value of something has changed. The same interface will work for oracles, where I go to the Chainlink contract on chain and say, hey, I want to buy access to this. And so my goal is that Chainlink oracles, and Sergey's goal is that Chainlink oracles are the easy, happy path that people building contracts on the Agoric system can simply go and say, I need data. I'm in a data-rich environment. Give me some. And what they get is they get the Chainlink oracle for that data on the easy path. And we're an open system, and people can do all sorts of things. But I know that as I said, I want not just a piece of software. I want a community that backs it, and that's a huge, huge, huge value. What is some of the key components that need to be built to help the network? Our network or the Chainlink network? To help the Agoric network, well, we're now at alpha. We have an alpha that has been up, or rather, we have an alpha release candidate that we're in the last week or so of testing to upgrade our testnet to alpha. Our testnet right now is the inter-blockchain communication protocol version of Cosmos, and we'll be upgrading to the Stargate release, which is in progress, that has Cosmos as well, and we'll be getting our alpha APIs onto that testnet. We will then be heading towards a beta net that has the first version of our actual economy, and it may be that we'll be doing staking at that point, but it'll be incentivized testnet at that level. Yes, Berlin. That was our first event, and it was awesome. And we were a sponsor, so hence why we have the whatchamacallit. Let's see. So key components. So there's a whole exciting line of future of us working with Chainlink, because there's first simply getting Chainlink existing oracles on our chain. But frankly, that whole Oracle thing, the SLA things, the automated balancing and all those kinds of stuff, those are smart contracts. We've got a smart contracting language that a lot of people can program in, and that gives you very safe compositionality. So I look forward to a future where people implementing Chainlink are excited to have parts of that contract world migrate onto our chain and be implemented in our infrastructure. And there's sort of this nice nesting use of our infrastructure using the data that it bought through contracts that are running on our infrastructure in Chainlink. So very excited about that. Oh yes, I am passionate. I love this stuff. I have loved this stuff for 1989. That's a while ago, and that was not my first rodeo. So, so we've been doing high-end, large-scale, secure commerce, distributed system technology across brokerage houses. My previous gig to this was a multi-billion-dollar payment instrument. So this is we care about mainstream commerce a lot, and so. Okay, I will not elaborate now on how the Agoric stablecoin operates. That's something that will be coming out and we'll be talking about in the next couple of months, and we're very excited to talk about it. We, got approval for our white paper, and that'll be coming out and that sort of thing. But we're still just a few months ahead. What advice would I give to a UX researcher and designer? I've got some very concrete advice. So first off, you should come and watch our Zoe presentation because I characterize the current world of UI and UX on blockchain as send money to a random number and hope something good happens. And for example, that bug that Dan Robinson and Georgios Konstantinopoulos, I might have added a syllable in there, at Paradigm debugged was, someone sent $12,000 to a random number and it turned out to be the wrong random number and there's nothing they can do to get it back. That is an insane UI experience, right? That's just completely inappropriate. So look at that. Look at Belay, B-E-L-A-Y, which is one of the object capability UX systems out there, and look up pet names, because pet names are one of the main mechanisms. You'll see that in our new wallet in Alpha, and you can see bits of it now, but it's a little rough. But pet names are one of the ways where I can have a name for something that underneath the covers is secured by, a public key, but I never should experience the public key. What I experience is this is the DeFi exchange that my financial advisor recommended that I make my contributions through, or that and that several other people that I respect agreed was the one. And it doesn't matter whether it's Uniswap, it doesn't matter whether it's AutoSwap or Curve or Balance, whatever. It matters that it's the one I chose to work with. So it might be Vinny down the street, who's the most reliable bookie I know, right? And so it's important that it's the one I intended, not that it's something famous, right? And so pet names, object capabilities, and Belay in particular is a nice UI that combines some of those, but there's several others. Sure. So it says, can I elaborate on how OCAPs interact with the blockchain? Yes. So the code that I showed you, which I could pop up here if people wanted, but the code that I showed you was object capabilities, right? Where I mean, the thing is, object capabilities is a security discipline that comes out of secure operating systems, and indeed the SEL4, the most secure operating system on the planet by almost any metric you can imagine, is an object capability operating system. I was architect for the Midori operating system at Microsoft. There's several out of this thing, and they're well suited for manufacturing control, secure systems, and in particular, it turns out, smart contracts. And so what it means is and let me just do a quick share. Because then I can gesture. The quick share here is, right here, this guy passed in an underlying asset. And here we got to abbreviate it. We didn't have to pull it out because we were just going to pass it through. But what they passed in was an object, right? It was, if this was a UI, I passed in a component in React, or I passed in the window object, or I passed in the font. And this component doesn't care what font it's selling. It's just gonna, if you pay the price, I'll give you the font. Done, right? And so being able to pass in just the object, right? If I'm passing in a concert ticket, do I want 0x87523? And in theory, that's a concert ticket, but maybe it is, maybe it isn't. Or do I want an object that has a venue entry and something that I can click on and gives me a map and has things that let me query about the date and time and put it in a scheduler and automatically wire to a calendar? I want objects. I want the world of the last 20 years of programming that most blockchain systems are still trying to catch up to. And so an OCAP is just at the programming language level, not at the how do you securely implement in crypto systems and operating system, which is, there's PhD theses about how to do it right and lots of analysis for it. But at the programming language level, I just pass you the concert ticket, right? And that's just an argument when I make the offer to this thing is, I'll give you this concert ticket if you give me $4,000 or $400 or $40 or whatever it is, right? And now I've got a covered call that I can sell to someone to say, you have the ability to get this concert ticket for $400 until Friday. And after Friday, it reverts back to me, and then I'm going to go off with my concert ticket and go to the concert, right? And so that compositionality, that ability to compose things, instead of, the Synthetix talk beforehand that Justin was talking about. I mean, he did, 2 years ago, you said being able to compose components, and people were like, they look at you funny. Do you mean Zeppelin OS? I don't know, right? There were 2 examples. That's how hard it was, is there were 2 examples, and they weren't very good, right? I mean, they were great for their time, but compared to real composition, they're nothing. What happened with DeFi is suddenly people realized that I, as a user, could have a transaction that spawned multiple blockchains, right? And, or sorry, not multiple blockchain, multiple contracts. And so I could get a loan, make a transaction here, get something out, and done. And that was composition. Well, then they discovered mashups, and Justin in Synthetix talked about how there's a cool contract. I will take it and I will change it for my purposes, now invalidating everything we might know about its security and reliability and gas costs and everything else. So all it does is save me a little bit of development time, but it doesn't give me any assurance, right? And that's great. It's valuable. People were doing that in the 80s, you know, in C code, and they would make changes, and then they'd have, you know, pointer bugs and stuff like that. We're reprising the same crap, right? It's good, it's valuable, but it ain't there yet. And what this is this instead take a component that has tests around it, right? You know, and you know, these tests running over on the right, those tests are, you know, a set of unit tests. They run in CI. Every change automatically reruns them. Sort of standard development practices that companies across the world use to get high reliability, high assurance commercial, you know, financial products, and we get to use that here. And now if you are going to do something that required a covered call, take this code, don't copy it, you know, just instantiate it and use it. Import the library, right? You know, this thing up here, I don't know if this one happens to import any other library, it probably doesn't, but it's just JavaScript, right? This imports 3 helper classes, right? I mean, I can import, you know, jQuery and you know, fancy random crypto library written in JavaScript and a new Snark library, and, you know, it's just JavaScript. There are millions of programmers that can help do this stuff. If I write a fungible token on Agoric, does that have a private key? Let me see. I'm going to search for make payment. So one of the things we did beginning of July is we did a we did a internal hackathon so that everyone in our company would actually build with our library, right? We wanted to, you know, does our developer experience meet our expectations as people who have done a lot of development in a lot of different languages in a lot of different companies and shipped a lot of products, right? And one of the things that we realized out of that is, in spite of needing NFTs or tokens only in a few different kinds of contracts and, you know, or relatively low percentage, most of the ones people would build for DeFi, because they would have governance tokens or they'd have liquidity tokens or what have you, you know, most of them would end up having their own token, and it might be fungible, it might be non-fungible or whatever. So if I find, let me just find a random example. Mostly I have, you know, when I do a quick search, I mostly end up with test cases. So if I, and it's so trivial that, well, I'll just, you know, look at that. Oh, no, that's too simple. That's what it takes to make a new fungible token, right? So the thing is, a token is just, you know, a balance. So a lot of the design of the contract architecture is what we call electronic rights transfer protocol, ERTP. And it is documented in our website. So if you go to the Agoric website, you know, rather the getting started documentation, and we haven't updated it quite for the alpha APIs, but it's close. And you go to the APIs, and that's probably not readable. And you'd be able to learn about issuers and mints, and the line to make a new digital currency is basically, well, that's pretty much the line right there. It's make issuer. Now these are test cases. Let me see if I can. I will go to. Oh, here's a test sell tickets. Well, I will stop sharing my screen and I'll find one for you. But it's basically a one-liner. You know, it is. Give me a new issuer with a new token named foo, and fungible, I'm done. I just get a new issuer and I can now store it in things. I can have payments about it. That covered call, I can have the covered call that closes over those assets, and it just all works. And I can use our pegging infrastructure, so I can take that new thing and I can transfer it over that pegging infrastructure over to, for example, a Cosmos hub using IBC, or now that people are working on IBC over to Polkadot, I'd be able to take it over and send it over to Polkadot. I'd be able to do all of those things, and I can then have people that make offers that say, I will give you a concert ticket if you give me 1,000 of those tokens that you've got. You know, and where they say specifically the tokens that you, James, have got, not, you know, not some other guy, right? And you hand him the issuer, so that when he's making those offers, he can verify that the things he get back actually are those tokens. Or he can tell the underlying system, I will give him this concert ticket if he gives me 1,000 of these things. And the underlying system will prevent you from getting that concert ticket until I get 1,000 of those things. And it provides that safety and high assurance that we just don't see currently in existing blockchains, and that is fundamental and pervasive throughout the implementation and execution and architecture of our system. And the same logic, if I just say comma set, it's a non-fungible token. So the testnet, I don't know whether it has the alpha release candidate, which we just got done last Friday, right? So it may already be up on our testnet, but we're now undergoing testing. So I think we'll probably just wait for the alpha release, which is, you know, next weekish, and get that up on our testnet. So our testnet has it, but developer experience, right? It's just you go to that site that Tatiana linked. You can follow the instructions there. It's all open source. It's all on GitHub. You can deploy it. One of the key things is, I, as a developer, I did a lot of development on, you know, laptops on airplanes while flying around. I want to be able to do development, iteration, testing, exploration of multiple contracts, working with each other, all that sort of thing locally. So, you know, all of our tools, it's like, you know, where you build an Agoric React, you build a React application where you say React init, and you get the UI directory and a server directory and a few other things. For us, Agoric init gets you a contract directory and a application server directory you could deploy in a hosted cluster to be able to bridge that, like your uniswap.com or whatever it is. And you get a UI directory that has, depending on what template you pull from, it has an initial React UI, or we have Svelte UI example, or just plain old JavaScript, right? You know, do whatever framework you want, use whatever framework you want. Because JavaScript. The data that needs, so the execution model of our system, in the simple form, so the way to think about it is, you know, it's not just secure JavaScript, it is deterministic execution of JavaScript. So we get persistence by, just replay from the beginning of time and play forward, and we will produce exactly the same answer on any machine running any standard JavaScript, right? And in particular on any chain of ours, right, or any machine of ours. And so what that means is, our persistence model is any JavaScript you want. Promises, you know, I send an asynchronous message to some other chain, wait, you know, to auction off an asset that I have here. I pass my asset as an object, as an argument to, you know, auction.bid, open paren, you know, contra ticket, close paren. The fact that auction is over there, now let me be clear, I am glossing over the actual details of of that syntax. It's not quite that, but it's close. But I'm doing, you know, and I get back a promise for the result of that auction. Right, or I get back a promise for the result of making the offer, which has the payouts and a few other things for a framework. The underlying infrastructure lets me do approximately what I just said, but then we have a framework to provide all the safety guarantees and automated systemic escrow and stuff like that makes it about easy. But yes, it's pretty cool stuff. So when we did our internal hackathon, right, we did voting abstractions, both for intended for use on chain and for dApps. That one was, you know, background project, so it didn't get as far as the others. We did a first gen of our stablecoin machine. That one's private until we do some more around it. But a first gen of our stablecoin machine that did automatic liquidation against our Uniswap equivalent, which is part of the, you know, which is is one of the early examples we built before we've revved our API with all of the feedback we got over hackathons. So it'll be improving over time as well, but it's pretty awesome. We did a pegging infrastructure to be able to use initially the IBC pegging in Cosmos to be able to peg atoms, you know, all of the, you know, Ethereum and ERC20 tokens that Althea does, etc. But it generalizes, so we'll be able to integrate with other peg systems, because of course we want to be able to peg directly Bitcoin, directly Zcash, directly, you know, other tokens. None of that's there. We got a lot of work to do. We don't have to do all that before chain launch, but we'll have a lot of it in place. So what data needs to be persisted? So we can do replay and get back to any arbitrary JavaScript state. For very large contracts, like, you know, this covered call, it's just one thing. It's tiny. It doesn't, you know, so it could just be persistent JavaScript. We don't care. For very large contracts, like a new token that has millions of entries, there it makes sense to use some additional features we have to be able to talk about. I've got a lot of data. I don't want to have it in memory, go push it out to disk in an efficient, asynchronous or synchronously accessible fashion and so forth. And so those libraries are not currently on in our alpha UI, alpha API. That's something that we'll be doing between alpha and beta. So all the performance and scaling things are not part of the alpha. It's just the usability of the programming model, and then alpha to beta is economy and performance and scaling. Stay tuned to our website and Twitter. We'll talk about chain launch and that sort of thing then. Sooner than you think, but I'll be a little careful until we get all our ducks in a row. But soon enough that it's worth starting to build on our system. Any recommended books? Crossing the Chasm, which Sergey recommended earlier today, I just love. I think it's great. Structure and interpretation of JavaScript structure and interpretation of computer programs using JavaScript. I strongly recommend for anyone who wants to learn to program, because otherwise, it's hard to learn how to think about programming at the same time you're learning JavaScript. Those are two big ones at either end. I've got a long litany of books, but I'm focused on my code here, so what am I going to do? Well, thank you all very much. I guess MakeMint works. No, MakeMint does not depend on a secret. MakeMint, well, you can actually find the code in our system, but if I go to its issuer.js, so the thing is, MakeMint is a JavaScript program. And it's a single package that has both mints to be able to create tokens, issuers to be able to verify that those tokens are correct, and it doesn't care whether it's fungible or non-fungible. That's a pluggable element, and we can do hybrid things because there's a lot of hybrid tokens, and it'll all the same infrastructure. The covered call that you saw, the markets, the auctions, all those things. They're perfectly happy with hybrid tokens too. That's fine. Something that is fungible to you but non-fungible to me, like shares are, right? Shares of Apple, they're sort of fungible until I vote. And then I voted these shares, not those shares, and it matters, right? And so there's these things that are sort of hybrid, interesting, fungible things that, again, falls out of the same infrastructure. We can extend our system in all sorts of different ways. So thank you all very much. Reach out to us on Twitter, reach out to us in email, and we're happy, or in our, we use Keybase for our open support channels. And look for us for other announcements with us and Chainlink. We're very excited about where we're going. Yes. Yeah, I like that poster there. Best thing to do would be info@agoric.com for starters. Otherwise, my name's pretty guessable. Thank you all very much, and we'll see you in the future of DeFi here.